to all. This is Kumar from National College of Technology and Department of Computer Science Engineering. So now I am going to tell about free face management with file systems. So it is a free face management concept. So file system maintains a free face list to track available blocks or clusters. For example, using terms of block or simplicity. So we are using a bit vector or a bitmap n blocks. So we have the 0 to n minus 1 blocks. So one is a block of I free and a block of I occupied. So block number calculations, number of bits per word plus the number of zero values words plus offset of first bit. So CPUs have an instruction to return offset within a word of first 1 bit. So free face management. So bitmap requires extra face. Example, block size equal to 4 KB and disk size equal to 2 per 40 bytes, and easy to get the contiguous files in a free face management likes. So linked free face list on disk. So linked list means a free list which cannot get a contiguous phase easily because it is used to different type of files. So it is a no waste of phases. So free face list is headed. So no need to traverse the entire list if free blocks are recorded. In a free face management, we have a grouping and counting methods. In a grouping, so modified linked list to store address of next n-1 free blocks in a first free block. So plus a pointer to next block that contains free block pointers like this one. So counting is because space is frequently contiguously used and freed with the contiguous allocation and allocation. So the extents are clustering. So keep address of first tree block and the count of following free blocks. So free face list then has entries containing addresses and counts. Free face management. So face maps used in ZFS and consider metadata input output and very large file systems and full data structures like bitmaps, good enough fit and memory, and thousands of inputs and outputs, and it divides device spaces into meta slab and into units and managing meta steps, and a given volume can contain a hundred of meta slabs. So each meta slabs has associated space map and uses counting algorithm. So but record to log file rather than the file system. So log of all block activity in a time order. So in counting format. So meta slab activity load space map into memory in a balanced tree structure. So it is a replay log into that structures to combine contiguous and the free block into single entry. So efficiency and performance. So efficiency depends on how disk allocation and directory algorithms used, and what the type of data kept in the file directory entries, and when the free allocations are as needed to allocation of meta structures, and how the fixed size are varying on the size of data structures. So performance is going to consider the keeping data and metadata close together. So we are using a buffer cache and a synchronize and free behind and read overget. So separate sections of main memory are frequently used blocks such as buffer cache, and synchronous writes sometimes requested by apps are needed by OS, and no buffering and caching, and write must hit the disk before acknowledgement. So asynchronous writes more common and buffer able faster, and free behind and read ahead. So it is techniques to optimize sequential access and read frequently slower than the writes. Page cache. So a page cache catches a page rather than disk blocks and using a virtual memory techniques and addresses. And memory mapped input output uses as page cache, and routine or input output through the file system uses the buffer or a disk cache. That leads to the following figures like input output without a unified buffer cache. It is a memory mapped input output, and memory mapped read and write outputs or functions are mapped with page cache. So then a buffer cache is only the file systems only. So unified buffer cache uses the same page cache to cache both memory mapped pages and ordinary file system of input output to avoid double caching. But which caches get priority and what replacement algorithms to uses in a unified buffer cache means they are using a memory mapped input output as well as input output using a read and write. So they are using a buffer cache as well as a file system to create in the priority unified buffer caches in a file system for free face management. When going to recovery, so is a consisting checking, so compares the data into directory structures with the data blocks on a disk, and it tries to fix inconsistency called can be slow and sometimes fails, and use system programs to backup data from disk to another storage device, and magnetic tape other magnetic disk optical, and recover lost file or disk by restoring data from backup. So log structure file systems. So log structure file systems are record each metadata updated to the file system as a transaction. So all transactions are returned to a log. So the transaction is considered committed once if it is returned to the log sequentially. So sometimes to separate the device or sections of disk. So however the file systems may not yet be updated. So the transaction is in the log or synchronously returned to the file system structures. So when the file system structures are modified, the transaction is removed from the log. If the file system crashes, all the remaining transactions in the log must be still performed. So in log structure file systems, with a faster recovery from crash and removes chance of inconsistency of metadata. So these are the free base management in the file system concept.